I'm Kathy Bowling, that's Lana Clark. We're with the UAS Ketchikan Campus Library, and welcome. The library is open to the public, and you can get your very own library card. We have access not just to the 30,000 titles that are here in town, but over 3 million titles across the state. So you can put a hold on an item, they send it to us, you come to the counter, we check it out to you, you bring it back to us, and we send it back to the home library. So it's just like, it's free, it's a library. So yeah, take advantage of that if you haven't already. So Professor Morgan, Barb Morgan, is our instructor of general studies, and she is teaching this summer. And let me see, we've got the one thing that hasn't broken with age is that I can still read without glasses. But you have Exploring Intertidal Sea Life. That starts June 20th. And then Plants, Lichens, and Fungi of Southeast Alaska starts July 9th. Her classes are so fun, and you get out there and to study your the subject. And there are scholarships for a few of your classes.
I think both of them might have scholarships still available. So yeah,
It's possible. So I have
checking
a
into
registration form, but downstairs, Brenda, when she's here from 8 to 4, will be able to get you signed up. So welcome, and welcome, Professor Morgan.
Thank you. And thank you all for coming and listening tonight. I have been teaching at the university for a number of years and actually grew up in this area. I've spent most of my life in this like southern Southeast Alaska area. And I'm called an instructor of general studies because I do the GED program and then a lot of different biology classes, mainly focusing on what lives and grows around here. And GED and biology don't fit under one category very well, so it's general studies. Anyway, I have been also focusing on climate change. This school year, I taught 2 classes, one in the fall, one in the spring, for the Tribal Scholars Program about how Alaska is changing due to climate change. And that's actually the second time I've done that. So I've been kind of focusing on this and paying attention to it because A, it's important, and B, it's something that I'm teaching about. There's a lot of changes, and part of my gaining knowledge about how Alaska is changing due to climate change is to go to the Alaska Forum on the Environment, which I've done a number of years, actually. Most recent was like 2019, 2020, and then this year, 2024. And watching how the information is developing as time goes by is enlightening. When I first started going to the Alaska Forum on the Environment was probably 6 or 7 years ago, 8 years ago, and I first went. And at that point, people were still kind of trying to like deal with the question, the debate, which is about whether or not climate change was actually happening. How do you deal with that? And in the interim years now, people aren't even addressing that anymore. It's like there's so much data that very clearly shows that climate change is happening. And so now the focus is on exactly how much climate change is happening and what the ramifications of that change are. How is that affecting different kinds of plants and animals and range extensions and die-offs and et cetera. So that's kind of what we're going to be focusing on now. I've actually done this presentation before, but I've updated it because there's so much more information in the last 4 years about how Alaska is changing on a finer scale level. So some of the data that you're going to see in here is like 5 years old. And that's because if you're looking at a broad range of temperatures, taking an average every year doesn't really make sense. Doing that every 5 or 10 years does make sense. So as we're going through this, if you're like, oh my gosh, that data's like 5 years old. Well, it's data that started in like the 80s or 90s, so it's still really current. So information is primarily from the Alaska Forum on the Environment, the International Arctic Research Center, which is IARC, and the Alaska Center for Climate Assessment and Policy, which are both UAS entities, and then the National Weather Service as well. So kind of some highlights. I wanted to start out with like kind of some of the things that, because it's like almost every year, it's like, oh, record-breaking this, oh, record-breaking that in different places in the state. So if you're looking at the winter, not this last winter, but the winter before, Reykjavik, December 5th, had a temperature of 40 degrees Fahrenheit. It's like, how can that be possible that anywhere on the North Slope has a temperature of 40 degrees Fahrenheit in December? That's like, right, wow, what? Battles had a highest winter temperature of 29 degrees, and then also had the coldest winter overall since 2012 to 2013, so it was a big temperature swing. The Bering Strait had heavy rain December 1st through 4th with severe icing and snowpack loss. Bering Sea, the December sea ice extent was the third lowest on record. Hooper Bay had repeated storms and damaging winds. Eastern Interior had a mid-December extended cold snap. Chicken got down to like minus 62, which is like cold. Really cold. Anchorage had 41 inches of snow. And remember, this is not this most recent year, winter. This is the winter before. So it was even worse this winter, last winter that's just getting done. So 41 inches of snow December 5th to 15th. So a near record 2-week total. Kenai had, on December 20th, had a low temperature of minus 31, which that's awfully far south for minus 31 degrees Fahrenheit. Coldest day since December day since 2001. Sitka, January 20th, wind gusts to 60 miles per hour damage a town. Ketchikan, February, it was the 5th wettest. We had 23.22 inches of rain. And then this last fall, we've continued breaking more. We had like almost 7 inches of rain one day last, like October, November, something like that. Like ridiculous amounts of rain. December 20 to the 22nd, in Unalaska, we had heavy rains and flooding. So that was winter before last. Last summer, then, Reykjavik had an average temperature of 43.2. It's the warmest summer on record. And it'll be interesting to see what happens then this year. Is it going to be, again, a warmer summer, or is it, who knows, might be colder again. Beaufort Sea, the August average sea ice extent was the 4th lowest on record. Statewide, 19,000 lightning strikes between July, it was a 24-hour period, one day, but bridged between the 24th and 25th of July. 19,000. West Coast and Interior had a rare low elevation summer snow on June 1st and 2nd. Awfully late for snow. Nome had 53 days with rain. It's the 3rd highest number in the past 80 summers of having that many days of rain. Statewide wildfire burned less than half the average, which comes after years of several years in a row of much more than the average. So these wild swings that we're seeing throughout the state, various different things, is typical of climate change patterns. Okay, Fairbanks had an average temperature of 42.9 Fahrenheit, which is the 3rd warmest summer on record. Golcana had the driest summer since 2004, with only 43% of its normal rainfall. That's amazing. Juneau on August 6th had severe flooding from the Mendenhall River with the glacier lake that outburst kind of a thing. Anchorage had 48 days with rain, which we're like, what, only 48 days with rain? But in Anchorage, that's a lot, okay? 2nd highest summer total. Homer had its wettest summer rainfall, 233% of normal, which is pretty substantial increase. King Salmon, the 2nd wettest summer, 141% of normal, and Sitka's average temperature of 58 degrees was the 3rd warmest summer on record. So it is a substantial kind of, these changes are remarkable. And this is just the changes due to with weather events happening, okay? When you start looking then at what is that doing, you get things like this. So marine heat wave impact. So all of that data I was just talking about is stuff that's happening on land. The ocean is also warming up. And that marine heat wave often there's a few years ago, 2014, 15, 16-ish, there was the blog people called really severely warm ocean temperature. the Gulf of Alaska, kind of stretching down towards the equator quite a ways. That blob drove the Pacific cod collapse. I'm going to go into a little more detail about that in a bit. Prince William Sound salmon mortality events happened in 2019. There's been recent crashes of the Yukon and Kuskokwim Chinook runs. I'm going to talk about that a little bit more and why that's happening. The Bering Sea had unusual mortality events of seals and birds, all stretching from the 2018 to 2022. Sea ice-driven Bering Sea crab collapse in 2018, and the recent record Bristol Bay salmon runs. So just really Chinook salmon and other species of salmon are having collapses in the big rivers, but the Bristol Bay salmon were doing fine, and the reason for that is because the Bristol Bay salmon are sockeye primarily, and sockeye spawn in deep lakes and ponds, mostly lakes, which don't have the same, they're not as vulnerable as rivers and streams to the warming. It's a much bigger body of water, and so it can stay cool and not be as stressful for the fish. So the sockeye are doing fine. The other salmon are not in the rivers. So more on that in just a minute. There have been a lot of migration and other shifts. So the white spruce is expanding its range because the permafrost is melting. The Arctic chum salmon is expanding. Moose have been expanding. Caribou are having migration shifts. There are areas that people used to be able to get caribou and live off of caribou, but the caribou aren't going to those places anymore. Permafrost that's really super melted is not easy for caribou to walk on, but moose are fine, so moose are moving into those areas, which is a big change. So there are people in northern and western Alaska that used to call themselves the people of the caribou. They're now calling themselves the people of the moose. Early arrival of trumpeter swans. Trumpeter swans are heading north, many birds, not just trumpeter swans, coming through here a little earlier, getting north earlier than ever before because the water's thawed out. Why not head north? Okay, not a bad thing, just something that's happening. So observations of record-sized walrus herds on shore in the fall in 2022, and that's kind of why are they on shore instead of off doing, why there's massive amounts of them up on the shore. That's not normal. And there's been outbreaks of the western black-headed budworm and the hemlock sawfly, and that includes here. You see them here. We've been seeing their damage here. And the spruce beetle, which is more in south central Alaska kind of area. And that's kind of a snapshot summary of some of the main big things that are happening due to climate change. So a little more details on the weather pattern changes we're seeing. So all of this is all of Alaska, the annual average temperature from 1900 to 2022. And you can see the green line is that it was kind of warming and sort of flattened out and then warming accelerated. The blue dots represent the 10 coldest years during that time period. The red dots represent the 10 warmest years during that time period. And other than the one anomalous red one back in 1925-ish, all the rest of the red ones are all since 1980, and the cold ones are all before 1980. 1980 was a big shifting point there. What that means is the annual temperature trend for the past 50 years in the different regions in the state. Ketchikan, we've on average warmed by about 2.5 degrees Fahrenheit, which is hardly noticeable. It's there though, and that is enough to start making some changes in the timing of when things bloom, reproduce, etc. But look on the north slope, that's a 6.5 degree temperature increase. That's a substantial increase in temperature during the past 50 years. And places in between are gradually smaller and smaller as you come further south. But the 6.5 degrees or the 4.8, 4.6, that's a pretty massive increase in temperature. Annual precipitation trend for the past 50 years. Again, the further north you go and the further west you go, pretty much, the more of an increase of precipitation there is. The North Slope a little bit less than the western and eastern parts of Alaska. And then as you come further south, we've only had a 4% increase in our precipitation here, which is still noticeable, actually. And so a 19% increase is that's a lot more precipitation than they were getting before. If you look at only the Arctic area, okay, so the Arctic part of Alaska, the Arctic Circle passes. So if this is the state of Alaska right here in the end, the Arctic starts like right about here. So this is like basically the northern half of Alaska. And you can see right there at 1980 again, 5 lowest are those blue dots on the far left. 5 warmest are all like centralized, congregated since 2010. And 1980 is that tipping point, kind of where things really changed all of a sudden. Flatline up until then of like no real temperature difference, and then all of a sudden an increase that's been just moving right along pretty steadily, which is a pretty remarkable difference. Yeah.
Did something happen in 1980 specifically that, or is that just a tipping point?
This has been something that's been happening and working, like developing, since the 1700s. And then 19, like late 70s, early 80s is when we just finally reached that point where it's like, yep, we're warm enough now and things are going to start being noticeable. So then, looking even further north, Utqiagvik up on the north slope there, used to be called Nome, now it's gone back to Utqiagvik, right? So if you look at the 1921 to 2023, so about 100-year temperature range here, again, the 10 coldest are before 1980, and the 10 warmest are, well, 9 of the 10 warmest are from 1980 or more recently, okay? And if you do a trend line where you go, you kind of split that. You go, okay, Utqiagvik was getting cooler and cooler and cooler, and then all of a sudden started getting warmer and warmer and warmer. So that's a pretty dramatic change for them as well. And so this one is for the summer, June through August temperature average for that 100-year time period. But if you look at just the October average, this is it doesn't show up as well because it's kind of sunny out, but if you look at the dots are red kind of scattered across the top, black scattered in the middle, and blue on the bottom from 1920 through 2020 over here. And then degrees Fahrenheit is up the y-axis there, the vertical axis. And you can see that there's been a scatter of warmer and cooler years all through that whole time period until 2000. And then all of the dots in that circle are red. Those are all warm. So in October, in Utqiagvik, all of a sudden, starting in the year 2000, there are no more average or cool Octobers. They're all warmer than normal.
Wow.
Winter is delayed by a full month now in Utqiagvik. And that has actually pretty major ramifications for them. Okay. That's a huge shift. This is something I was learning just this year. People are like really nailing this down. So when I was up at Alaska Forum on the Environment in February, people were like, "He says what?"
Mm-hmm.
That's a whole month delay is amazing. So that means that the sea ice is not freezing solid to the North Slope for a whole month of delay. Okay, that's gonna have some. We're gonna get back to why that delay is a problem. The snow length season in general, you can see from 1997 through 2018, and with 1997 at the top there, and then the gray bars are like how long of a snow season there is, and it ranges from like September 27th through like June, whatever, almost June 10th. And longer ago, those bars are in general longer, and the red bars show that they are on average getting narrower as you come closer to the present time. So the Alaska snow season length is shortening on both ends, spring and fall, as a whole in Alaska. Some places more so than others, but winter's getting shorter. So a summary of all of that, throughout Alaska, throughout all seasons, temperatures are increasing. Precipitation is increasing. Snowfall is decreasing, except above 10,000 meters. 1,000 meters, sorry. Too many zeros there. 1,000 meters. There are some regional differences in that. Some places are getting more or less, but in general, if you look at all of Alaska as a whole, these trends are true. And small changes in temperature, precipitation, snowfall can have large impacts. They are working more and more as they kind of get going and as they work through data to do high resolution climate information on like smaller and smaller locations, kind of smaller scale, so that you can have like what information what's going on here where I live. Everybody wants that. How do So we're working on that. It takes a little while to develop that. So effects of all of these widespread changes. For one thing, the growing season is getting longer. Like everywhere almost. Intiaguic, furthest north point there, is 334% longer than it was before. That is huge. That increase in the growing season in Intiaguic is a lot. Yeah. There are a few places where it's a little bit shorter. You see the blue numbers here, like -7%, -9%, -12%, -10%. The Alaska Peninsula kind of out the losing chain a little bit, seems to be getting smaller, but most places it has gotten bigger. +34% in Kotzebue, +20% in Nome, +18% in Bethel, +9% in Juneau, +2% in Sitka, +4% in Ketchikan. So ours is not that much longer, but it's a little bit longer. And it's getting to be a little bit noticeable. It's not +334% though. So can you imagine? We could grow gigantic dahlias. Another thing, with the melting sea ice, we talked about Alaska and the terrestrial environment and what's going on there quite a lot. But the oceans around Alaska and what they're doing have a really big impact, not only on what's living in the ocean, but then also the terrestrial area as well. Okay. So in general, since 2000, there's been a 25% decrease in Arctic sea ice extent in September. So in September is when it has melted back as far as it's going to melt back. And that's when they want to measure how far back did it melt before it starts freezing and back towards land again. In the 40-year period since satellite measurements began, the annual minimum sea ice extent has decreased by 33%. Arctic winter sea ice maximums were at record lows in 2015, 2018, which is the same time period where there was that blob of hotter, it wasn't actually hot, but warmer water in the ocean. Sea ice melted back. I mean, didn't form as much. And they've talked more about why that was a big problem. Permafrost thaw has impacts on transportation and infrastructure. If the sea ice is not as dense, isn't covering as much of the ocean, then the ocean can keep the land warmer. If the sea is frozen over, the land will be cooler. So the melting sea ice means that permafrost is melting back more.
Is that very common, that when permafrost is affecting the infrastructure?
Yeah. Permafrost, and it's just like permafrost melting is affecting human structures like throughout the whole state.
Even in Southeast Alaska?
We don't have permafrost down here.
Okay.
Yeah. Alaska has some of the fastest glacial melt rates on the planet. Okay, so what's the decrease like, right? So the Bering Sea is the part of the ocean that is kind of, again, the map of Alaska with my hand, right? Bering Sea is over here. It's above the Alaska Peninsula on the Aleutian Chain, but isn't up above Alaska. It's just kind of off the western side of Alaska. And so the spring meltout date is an important date. When does the ocean ice melt away from the ocean? When does it go away? Because then that means that the land can warm up more, right? So that meltout date is important, and it is getting earlier and earlier and earlier in the year. In, was it 2018 there? It melted out in early May. It was like earliest ever. People were like, oh my gosh, what's going to happen here? But you can see it's getting earlier and earlier on average. And that is going to continue letting Alaska warm up more. If you look at the Chukchi Sea, which is above Alaska, and the Beaufort, so Chukchi Sea is over here and Beaufort Sea is over here. So the Chukchi Sea has a 37% decrease of ice here. And this is the average ice extent, May through October, so the summer months, average ice extent. So it's melting back further and further each year. So there's been a 37% decrease in ice coverage from 1979 to 2023. And the Beaufort Sea, which is over like here, this far part of Alaska, has a 55% decrease in ice coverage during, not quite sure why they did this. They had these 3 nice graphics, but they had slightly different information presented on them. I mean, the same idea, but slightly, so this is all year, the annual minimum ice extent for the Beaufort Sea. Year-round ice is 55% less than it used to have, which is a drastic reduction in ice. So what does that mean? So again, we're off Western Alaska here, Nome, and you can see right there. And so this is this is not the sea surface temperature. This is the temperature of the water at the bottom of the ocean. Okay, mostly when you talk to people and they're talking about the ocean temperature, they're talking about the sea surface temperature. It's a lot easier to measure that. You can do it by satellite. They wanted to know what the bottom temperature was. How far down in the water column has that warmer water penetrated? Mm. And in 2010, the bottom temperature, it blew pretty cool. In 2019, you can see that cool water had been pushed almost up to Nome, and much warmer water had been pushed way up inside of that. So what that meant was that there was no cold water barrier preventing certain fish from pushing up into that area. Okay, so the large predatory fish don't like it when it's that cold. They like warmer water. The predatory fish is really active and really kind of needs that warmth to keep their metabolism going. If it's too cold, they're gonna, they can't move around enough to get enough food to eat, right? So predatory fish, that cold bottom water keeps them pushed down towards the lower part of the Bering Sea. So they move north. The large predatory fish being pollock and Pacific cod. So this these numbers were collected off of Nome kind of area, and in the northern part of Bering Sea, pollock increased by 5,421%. Pacific cod increased by 1,153%. The small forage fish that they were eating, the smelts, decreased by 70%, and the Arctic cod decreased by 100%. If it decreases by 100%, it means they're gone. And so the collapse of the Arctic cod due to the temperature problems what I was talking about earlier, the reason why is because that cold water being pushed further north and allowing the pollock and cod to go, Pacific cod to go up there, they got eaten. So it's a combination of the temperature and then also the predatory fish. Yes.
Do you mind if I ask a question?
Go ahead.
So the predatory fish are moving north as the temperatures shift, but the small forage fish are not moving.
They were already up in the northern part of that area. Yeah.
Mm-hmm.
And so they were fine. There was, they had their whole like ecological balance going on up there, and so they were doing fine. But then when these pollock and Pacific cod that are not normally in that area, they were invasive species basically. They were able to do a massive range extension into areas they've never been before, and so they were invasive species. And they were like, hey, look at all these yummy fish. And just chowed down on them.
I gotcha. So it's just one's moving quicker than the other, just or one's not moving at all
No, one's not moving at all. Really.
because it's already
The population was
Stay
comfortable.
there and be.
Yeah.
yeah, it's already comfortable. Gotcha.
Doesn't that mean that the large predatory fish will soon have a big collapse because there's no little fish left for them to eat?
And that's exactly what happens, biologically speaking. And actually, how people actually figured out this was happening was because people in Nome were looking out over the ocean and were like, what's that out there? There's lights out there. And they started, like, looking, binoculars, whatever, looking, and the huge, like factory trawl boats had moved. The factory trawl boats are fishing. They're targeting the pollock and the Pacific cod. So as they moved north, those trawl boats moved north with them and were catching them. And so they're like, what are they doing out there? What, they were alerting scientists, like their science partners, whatever. There's boats out there fishing. So they went out to see what they were catching, basically, and measured the water temperature and figured all this out. So it's not going to be sustainable for those fish, partly because they're eating themselves out of house and home, and partly because they're getting targeted by fishermen. Yeah.
This might be a silly question and isn't exactly climate related, but more economic.
Yeah.
If there's such a plethora of Pacific cod or whatever that commercial fishermen are interested in, would it be reasonable for there to be larger quotas for commercial fishermen to kind of
That opens up a gigantic can of worms. Because, and I'm not going to go into this much because it's like a whole humongous issue. But the trawl industry has a big bycatch of king salmon and halibut when they're small, and to kill things like killer whales and etc. There's a big movement right now to like totally shut them down because it's not a sustainable way of fishing. And they are targeting fish species that turn into fish sticks and McDonald's fish burgers. And part of their bycatch is halibut and king salmon, which are much more desirable fish. So, and they're killing killer whales. I mean, it's just like. Anyway, I wasn't going to go on and on.
I got you. Thank you.
Okay, so another reason why sea ice is important is, and then this I actually learned this fairly recently. There are species of algae that grow on the bottom side of sea ice, and then other things eat it. So the top picture on the right here is krill, and then there's some small forage fish of some species I don't recognize. Might be a smelt, and then those are eaten by things like birds. So with less sea ice, just area-wise, that is a great reduction in that algae. And so then there's less krill and et cetera, the food chain. So there have been mass die-offs of seabirds, and there are people that are like, oh, they're starving to death. Oh, maybe it's harmful algal blooms. Maybe they are too warm because the water's too warm, all these different things. And the algae on the bottom of the sea ice feeding the food chain is very likely at least part, if not all, of the reason why we're having those massive seabird die-offs. And then like thousands of birds, lots of them, not like just thousands and thousands of seabirds. So these are some of the different things that people in the area are studying, and you will notice the poor body. So the ones that they're found when they find them, their body is in poor condition. They're skinny. They usually don't have any food in their stomach. There are annual die-offs every year, and so the poor body condition of seabirds, people really are like they're starving to death. Looks like. And then if you think back to when I was just saying that there was the year when the warm water got pushed way up, and that allowed the predator fish to come up. Some of the forage fish that they were eating and like killing off are normally bird food. So for the seabirds. So that's kind of a reality. So the Bering Sea ecosystem, kind of a summary of that. The loss of sea ice in the Bering Sea and elsewhere. But anyway, there's a transitioning marine ecosystem. I should say too that warm water that got pushed up into the northern part of the Bering Sea did not persist for forever. It was like a year or two or something, but then the cold has been pushed back down into that area and that warm water is gone. So it's like good, okay, it wasn't permanent, but we don't really know what the long-term ramifications are because that happened like maybe 3 or 4 years ago or something like that, not very long ago. So how is that all gonna play out? We don't know. That lack of a thermal barrier though, really, even if it was just for the 1 year, it could come back at any time too, and that's kind of worrisome. What's that gonna mean? Less algae is a problem. Warmer sea surface temperatures is a problem. And all these things have cascading ecological effects. And they add up too. If a bird is already stressed because it's not getting enough food, then there's a big harmful algal bloom that happens. That effect can add up, and they might not take much of the toxin. That it's already weakened because it's starting. Not much toxin could be more than it can handle. Industrial activities are responding. That's when you're getting to when the trawl fishing fleet follow the predatory fish and continue harvesting them, harvesting in an area that they've never been in before, and then they have bycatch where they've never been before, and that could be a problem. So moving on, more melting ice. Yeah.
Well, I was wondering about El Nino and La Nina, super El Ninos. Those don't affect the Bering Sea, do they, or do they? Or even if they do or don't, could you explain that, how those things work? Because they affect us, don't they?
They are affecting us right now. The El Nino it's called ENSO, El Nino Southern Oscillation. It's between El Nino and La Nina. And this happens, it actually starts off of the coast of South America, where it's either like a warmer current than normal, which is El Nino, or a cooler water current than normal, which is La Nina. And that happens because the jet stream dips down and lets colder air go down or doesn't dip down anyway. And then that cooler or warmer water, then the effects of that transfer up to us. So if there's an El Nino year, which we're in an El Nino time period right now, we are warmer than right here. And we are currently feeling that. I'm going to talk about that in a minute. So that switches then too, depending on quite a few different factors. And I can do a nutshell version. There's more to it. But they're predicting that the current El Nino is probably going to end within the next month to 3 months. And then it will either be ENSO neutral, which is kind of like neither, or it might flip into a La Nina, which would then be cooler here. The effects are most felt down by the northern part of South America, but they do transfer further north. They affect us, and they do affect the Bering Sea to some extent, but not as much. Yeah. So melting glaciers. This was just pretty clear starting 2002, 2017. Really nice linear graph here of how much ice is melted off in Alaska. You go up to Juneau, one of the easiest glaciers to access, Mendenhall Glacier, has melted back so far. It's like, where are you back there? It's like, and I can remember. It was like way out. It's like this big, massive glacier. Now it's like this little, and it's would melt, and that's just typical of all the glaciers in Alaska. They're melting back, and then that has impacts too. It's just like the cooling effect of them is being reduced then too. Permafrost melt. So on the left is kind of a permafrost distribution. The dark blue is like really frozen, continuous permafrost. The surface will melt during the summer. It's called an active zone. In the farthest north part, that active zone is usually only about 6 inches deep. Pretty cool. And below that is still solid frozen ice and organic material. The further south you get, the more discontinuous and patchy the permafrost gets, and then the deeper that active zone melts down in the summertime, that top surface layer will melt down further. With more and more permafrost melting, active zone is melting down deeper. Trees that were able to stand up straight because it was only that top little bit that was melting, now it's melting down deeper and deeper below their roots and they don't have the support, and so they're leaning, and they're calling them drunken trees because they're just leaning all over the place and trying to like they're falling over. Roads that have been built on the surface because it's it's always frozen. It's not always frozen, and so roads that had been level are now like wonky and like hills and valleys in them, and it's hard to drive on them. They're having to do some tricky kind of like trying to keep the permafrost supporting the Alaska pipeline from melting by like I don't really exactly get if they're trying to pump
Oh, like the
cold in
thermal
or
transfer thing.
right. They have some thermal transfers. I'm not sure if there must be. I'm not sure if they're transferring heat out or cold in or maybe both.
Heat out.
But to try to keep the ground frozen there so that our pipeline is not busted would not be good. Okay, so then on the right hand side here, this map here is kind of a permafrost hazard zone predicted for 2060. Like what areas in Alaska are the most likely to like really be melting? Which I thought was kind of interesting. We're down in like the bottom part, like all of southeast and south central, there's no permafrost there. So this isn't something that we have to worry about here, but it's a major problem. There's what they're calling thermal cars too, where like the University of Alaska Fairbanks campus has a big area that has melted out underneath one of their road areas there, and part of the road's caving down into it. So this is affecting human like buildings too. Sea ice forms later in the fall. We kind of touched on that. And so the extent of the ice, how long it stays, and how thick it is all diminishing. So that's kind of revisiting that. And part of the reason why is because now, if it's refreezing later, so it's not becoming land fast for like a month later in some places, that allows the fall and winter storms to cause a lot more erosion happen on the North Slope area, all of northern Alaska and western Alaska. And so there are areas that are losing like 70 feet a year back from where it had been. Not every year, all the time, but there are places that have lost 70 feet in 1 year. There are whole villages that desperately need to move because their land is going away. It's eroding away. Coastal storm damage since 2000 has been now upwards of $200 million, which is a lot. That was before Hurricane Merbok, which I'm going to talk about in just a second, this number. So it's even more than that now. There have been at least 17 now state federal disaster coastal storm events that have occurred since 2000. Some coastal communities have had to relocate. While average rates of erosion on Alaska's coast are nearly 5 feet a year, some areas are seeing erosion rates as high as 70 feet per year. Typhoon Merbok happened in 2022, and that was a storm that happened. There was a few different factors that all came together. There was a typhoon in the Pacific West. There were high altitude winds. There was a push from the jet stream to really push that up forward, up north. And there was no ice on the west coast. The ice was not landfast yet. And so when all of those came together, there was a huge amount of damage that happened in the western part of Alaska, which is really unfortunate. This is Koyuk. The ocean was almost 14 feet above the highest tide line. Nome, the ocean was 9 feet above the highest high tide line. The Nome Council Road, the ocean and bridge were both damaged. Subsistence camp gear was lost. In Golovin, the houses floated off foundations. The ocean was 12.2 feet above highest high tide line. Shaktuluk lost its protective berm. The ocean was 11 feet above highest high tide line. Chivak mini boats were lost in the flooding. It greatly impacted the autumn subsistence that year. Hooper Bay infrastructure was damaged, including the tank farm. Houses floated off of foundations. Newtok had houses float off of foundations with severe erosion and infrastructure damage. That's a big area in western Alaska to be having so much damage. And this isn't going to happen every year. It might not even happen every 10 years, but the likelihood is we will have more events like this happen. Algal toxins off of Alaska. we've been having more and more harmful algal blooms. People are used to talking about them, calling them red tides, because in some parts of the world, the harmful algal blooms are red. Here locally, the red ones are not toxic, and the toxic ones are not red. Very tricky. So people have been starting to call them harmful algal blooms, or HABs, for short. And they have been happening with greater frequency throughout the state of Alaska. And they're not just a harm to humans, but we kind of think of it as being a problem for humans. It's also a problem for all of these other species: seabirds, whales, and dolphins, seal species, sea otter, sea lion, and walrus. And one of the reasons why they know that is that there's more and more scientific studies that people that are like from UAF or UAA, different universities, different places, different organizations, are working with people who live in the small communities in Alaska to say, hey, what's the weather like out here today? Like eyes on the ground, being able to go and take tissue samples, whatever, to be able to get more scientific data that way, which I think is a really great development. When people would find dead, like why are they dead animals, they started getting tissue samples and they were finding harmful algal bloom toxins in the tissues of all these different kinds of animals. Which isn't to say that harmful algal blooms are responsible for all those deaths, but at least some of them. Outbreaks by month have increased. Warmer waters stimulate algal blooms in general. Some of them are toxic, not all of them. We've got 3 species here locally that are toxic or can be toxic. The main one being Alexandrian catanella. That one causes PSP, which is the one that it paralyzes you. It's a nerve toxin and can cause death. So you will notice here that the 2 tallest bars of when the harmful algal blooms are happening is May and June. So this is a common kind of misconception of it. If it's a month that has R, then you're safe. Well, it's true that the 2 worst months don't have R's. So certainly don't eat shellfish on months without. I mean, don't eat them if there's a month without an R. April, May, June, July.
April has.
Oh, sorry. May, June, July, August. Sorry. But you can see here that there are incidences year-round of algal blooms that are toxic. So it's never 100% safe, but it's much more worse in the summertime. Marine mammal decline. So stellar sea lions have declined. Populations decreased by about 80% from the 1970s to the early 2000s. Some areas are rebounding, but not much and not consistently. In this area, Southeast Alaska, the population here seems to be doing fine. But the further north you get, the less likely they're doing fine. The same with sea otters. In the Aleutian Islands, population has declined dramatically. Has declined by about 95% or more since the 1980s. Declines are likely the result of increased adult mortality, likely by increased predation from killer whales as well. So it's estimated that only about 6,000 sea otters live in the Aleutian Islands right now, which is not that many that long of a stretch. So that's unfortunate. So the Gulf of Alaska annual average sea surface temperature from 1900 to 2020. So this is again the sea surface temperature. It followed the trend actually of the air temperature of Alaska. Basically, all the cold, the 10 coldest are all 1970 or earlier, much earlier. Almost all of the 10 warmest are since 2000. With a couple with 3 back in the 1930s and 40s. Okay, so that increase in the temperature of the ocean is pretty big, and it's going to have some big changes. The Gulf of Alaska sea surface temperature as a bar graph, kind of as they're doing these graphs here. This is the sea surface temperature from 1900 to 2023. The blue lines show the colder than average. The red show warmer than average. And it's a nice visual graphic showing, wow, all the bluest are over there. All of the red, most of the red ones, and especially there's this long band of red ones that are more recent. So they're making stickers of these. You can get stickers of these. So the warming of the oceans is really important. It changes ecosystems, causes ocean acidification, which the ocean gets more acidic as it absorbs more carbon dioxide. And warmer, this is a key point, warming oceans evaporate more water, putting more water into the atmosphere, which it can condense into rain clouds and come and land on us, for example. Okay. So increased precipitation. So heat in salmon in summer of 2019, thousands and thousands of king salmon and chum salmon died in rivers before spawning. In the summer of 2020 was not as bad, but still kind of the same deal. And they're seeing this continue to happen. And the reason why the terrestrial, the air temperature was really high, water temperatures in some of the streams and tributaries and rivers and whatnot exceeded 70 degrees Fahrenheit. And that's not good. Warm water can't hold very much oxygen, so they weren't able to breathe enough, basically. They're gasping for air, for oxygen. And that warmer temperature increases the salmon metabolism, meaning that they need to eat more. Okay. And while they're also not getting enough oxygen. And so they're now needing, instead of being able to like store enough proteins and fats in their tissues to be able to not eat at all or very little all the way up the river, now they're having to eat in the river as they're swimming and trying to get up to where they can spawn. So they're dying. Wildfires in the air, any area that has a fish stream that the wildfires burn down in the trees, that allows more solar energy to be absorbed in the water, removes that shading tree, so then the water's further warm, and that's a problem too. So there are ongoing research about this, but I basically just said most of this. The Chinook salmon in climate, poor food quality. The warmer water also makes for their food not live as well, so they can't find food as well. It's not as good. Migration, they have so like Yukon River is very long. They have a long way to swim under bad conditions. Warmer water may appear to reproduce reproductive success. Fish die early and produce fewer eggs. If eggs lack key nutrients, then they don't develop healthy salmon either. So kind of this whole cascading, like if they might die, if they don't die, they're going to be stressed. They might not be able to spawn as much, and the eggs might not be able to produce as many healthy fish. So, ongoing research on this, and so the people in this area, they're like, okay, we can't fish anymore. Their fisheries have been shut down. People who live along the Yukon River, nope, can't fish king salmon, but they're still allowing the trawl fishery to continue fishing and killing of, thousands, whatever, of king salmon as bycatch, and they just throw them away. So there's a real disconnect in the management of all of that. It's a mess. The growing season, you can see kind of here. I mentioned earlier the growing season's changing so much because of the temperature changes, and then this kind of reflects that because the places where it was the warmest, the most increase in temperature is greener. There's more water because the permafrost is melting down more, it's warmer, the growing season is longer, there are more things growing. There's some areas that are browning because it's either cooler there or the plants that were living there were adapted to cooler temperatures, and the warmer temperatures, they're like, help, what are you doing to me? And they're dying. So the plant populations and whatnot are definitely changing throughout Alaska. Like I said before, the white spruce are moving further north. Some plants are doing better, other plants are not doing as well. Where they can grow is changing. And that's a nutshell version for sure. People are focusing on plants that make berries, in particular berries that are desirable for humans to eat, because, like, for example, the lowbush cranberries in the interior of Alaska, the green line is the historical percent of healthy fruit that they find on the berries and on the plants, and then for it, there's less now. There's progressively. This is a mess over here. The legend is kind of weird, but there are fewer healthy berries per plant. They have a way of figuring this. I can't remember what it, but the upshot is that there's fewer healthier berries per plant now than there used to be throughout the whole summer, August, September, October, November even. Okay, and that's important for humans. It's also important for animals. There are animals that want to be able to feed heavily on berries before winter, and then if their berries are frozen and preserved through the winter, be able to eat those berries first thing in the spring while they're still good. And so if there's fewer berries, if it's warm later and so the berries aren't preserved, then that means fewer berries for animals to eat too. So it's difficult for people to get what they want at times, and it limits the food supply for animals. So they've done surveys with people about like what are the different problems with berries, and the top of the list is changing or increased variability of berry abundance. It's kind of a problem. The reason why berries can be so impacted by climate change is because the production of the berry on the plant, whether it's low-bush cranberry or a couple other kinds of berries, whatever, is that the bud for the flower is set on in the fall. And then it has to survive all winter and then have a good spring for that flower to then open and then be pollinated by a pollinator that has to be there. And there are some berry flowers that will only be pollinated by pollinators that buzz in the key of C. They're that specific, okay? And so the flower has to be like pollinated and then develop into a berry. And so it takes from fall all the way through surviving winter and whatever snowpack or lack thereof or whatever might be happening, a good spring with pollinators and then a good summer with enough warmth and rain, but not too much to actually develop a berry, which is a lot to have to happen in order to get a berry that you can pick and eat. They've now studied cloudberries, the lowbush, I call them, around here we call them bog blueberries, and the lowbush cranberries. And they're all being impacted for different, kind of slightly different reasons in different areas. And they have these different publications out. You can download them at casc.alaska.edu of Changing Berries. They're PDF documents you can download if you want to know more information about that. So I'll let you take a picture if you want.
What about our berries? Because our blueberries seem pretty variable from year to year.
And they are in kind of more so now, more variability now than there used to be. There's always been some variability. Oh, it's a good blueberry year. It's a good strawberry year. But there seems to be more variability now. And we are seeing, I'm going to get there here in just a minute. More, we have climate change effects here too. And so those are affecting our berry crops to some extent, but not as much as they're seeing further north. Humongous surprise to people is that beaver have extended their range. This right here, that's his Nome area. Okay, so they've been seeing them in Nome for a number of years, and then they actually made it up and around. They're just coming around the end of the Brooks Range here, up into the north slope area. Beaver are moving up in there, and beaver are known. They're like famous for altering water flow, and so they are altering the water flow, and that's actually helping permafrost melt more. And in some of the areas where they're seeing permafrost melt, a lot of the water that's coming out of those areas that are flowing into streams is orange, super, super iron rich and sulfur rich. And the pH is altered, and they're worried. They don't really know what's going to happen with the fish in those streams, but this was like last summer, like what is going on here? So beaver are moving north and changing things. So climate patterns. Wet summers lead to large berry harvests in general. Warm springs allow for the earlier collection of seaweed in areas that collect seaweed, including here. There's changes in food quality or location of that food. You might have to go to a different place to get what you want. The timing of ground freeze in relation to the snowfall. If the ground freezes before there's a snowfall, that cold can penetrate further into the ground, killing the roots of plants. So snow actually insulates the ground from that really deep, hard freeze. Caribou travel patterns over frozen tundra. If it's frozen, they have no problem. If it's melty, they have issues. So moose habitat is expanding, and people don't have access to their ice fishing grounds that they used to have. Since 2000, wildfires and floods have both become bigger and bigger issue. Wildfires, we've had 29 million acres of land burned and over 5,000 fires. Floods, $227 million spent on disaster relief. There have been 13 state or federal disaster flood events that have been related, because instead of some of the in the spring melt can be fast enough that instead of having the ice kind of melt, nicely, you just kind of do a soft exit in the rivers. There's like big, massive ice chunk breakup mess things happen, which can then block streams and rivers and cause flooding, and that's a problem. So in Southeast Alaska, we're finally in Southeast Alaska. Okay. 30-year climate normal comparison. And this is a little bit wonky because they averaged 1981 to 2010, which is in the right and the middle column there. And they also then averaged 1991 to 2020 of max, minimum, and mean temperature, precipitation, and snowfall. And then they found the difference of those to see kind of what changes we're seeing. So in Juneau, not much of an increase in maximum temperature, not much of a decrease in minimum temperature, mean temperature, no real change. They're getting almost 5 inches more rain a year and almost an inch more of snow a year. Like, what? Almost 5 inches more rain a year? In Sitka, their max temperature really hasn't changed. Their minimum temperature has increased a little bit. Their mean temperature has increased basically none. And they have a little bit less rain, more than 2 inches less rain a year. No real change to snow, apparently, because they didn't include it. In Ketchikan, our maximum temperatures increased slightly. Our minimum temperatures increased a degree and a half. Our average or mean temperatures increased by almost a degree. And our precipitation, we're the big winner. We get 8.29 inches more rain a year. I was like, we needed more rain. Our sea surface temperatures, this is blurry, it's kind of not, but basically it's our sea surface temperature is increasing in Southeast Alaska over time. Not at a drastic rate, but it's definitely increasing there. Who was asking about droughts earlier in Southeast Alaska? This is kind of 100 years of precipitation data. Dry spells are not unusual in Southeast Alaska, but we're not used to having like really super dry years. We haven't had one in quite a while. A couple years, 3, 4. We went from having like the wettest on record to then having 2 years of drought, and then another wettest on record. And that happened like 3 years ago. All 4 summers in a row. And people were like, anyway. So we do have drought, and we're actually currently in a drought. This was something I pulled up just a couple days ago. And you can see all of Southeast Alaska is in the abnormally dry category. But a transition from an El Nino to an ENSO neutral. So ENSO is El Nino Southern Oscillation, where that kind of goes back and forth between El Nino and La Nina. It is likely that transition from El Nino to neutral is likely in the next month. And then a La Nina may develop in like sometime in the June to August period at a 50% chance, or a July to September chance, kind of 69% chance of that. So we're probably going to be coming out of this drought. There's actually equal chances that we're either going to continue in this drought or go back to normal for the rest of the summer. It's hard to tell. And that information came from the Juneau National Weather Service. So I think that's probably pretty good. This is the NOAA seasonal temperature outlook for the whole United States. So May, June, and July of 2024, they're saying that for precipitation, Western Alaska is above. We'll have more rain, kind of just inside of that, a little bit more rain, but not a lot more. And then the rest of the state, including us, will be equal chances of like, who knows how much rain, about normal probably. Seasonal temperature outlook, we are going to be a little bit above normal. So likely above, so we're like this orange kind of color, so maybe a little bit above, leaning above normal temperature. Might be a little warmer, maybe dry, maybe wet, but a little bit warmer.
It looks like they actually thought you were down there and just continued.
It does, doesn't it? We've been dripped off I don't know. There are literally people who don't understand that Alaska is not actually in Anyway, and I wanted to throw this in here. This is kind of loosely related to climate change, probably. The European green crab have been moving north from San Francisco Bay since the 1980s. And they've reached Tamgus Harbor. This is Annette Island, right? Tamgus Harbor's here. Metlakatla is right here. So this harbor, which is southern facing, they have found these two crabs who were both, that the picture I took. No, I took a picture the same time as that picture was taken of the European green crabs that were taken from Tamgus Harbor.
Wait, these are European green
A
crabs
year
on the
ago.
left?
These are European green crabs. And you can tell they're European green crabs because they have 5 gnarly spikes or spot kind of like protrusions on either side of their carapace. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then in between their eyes, this is an eye and that's an eye. In between their eyes, they have 3 bumps. So 5 spines, eye, 3 bumps, eye, 5 spines. They might be green, they might be orange, they might be kind of brownish. They get up to about 4 inches. The problem with them is that they can beat up on and eat smaller than them crab, including baby Dungeness. They also like ripping up and eating the base bottom part of the grass. Eelgrass. Thank you. I was trying to call it crabgrass. Eelgrass that crabs like to live in. Anyway, so they've been there for a couple of years. Last year, ADF&G came down and they because one of the if it was this map, Bostwick is like right over here, right? And this is Bostwick Inlet would be right over here, which is huge eelgrass beds, lots of crab, and there was a huge worry. Well, if the crabs are in Tamgus Harbor, maybe they're in Bostwick. So they set 50 pots in Bostwick to see what was going on, and they caught no crabs. So apparently have not actually made it over there, which is good news. It'd be great if we kind of kept them from moving further north. Kind of a worry, though, is that they will eventually reach cold enough water that they're not going to be able to reproduce, and then they won't be able to go no further north. But with the waters warming, that line, who knows where that line's going to end up. Okay? So, Alaska is at the forefront of climate change. We are experiencing the impacts faster than the rest of the United States. What are we going to do? We all have a role to play. As individuals with multiple roles, parents, hunters, elders, scientists, as members of tribes, communities, organizations, as participants in a work to make the world a better place as citizens of Alaska, the U.S., and the world. So what are we all going to do? That's a good question, right? Part of what I do is that I help educate people. And that's something that all of us can do. And some of the climate activists that I'm kind of like listening to, scientists, they say the 2 most important things are to vote for people who are going to make a difference with climate change and to educate people about climate change. Third most important thing in my personal choices of what I do to like maybe reduce my emissions or whatever it is, but the 2 most important is to vote and educate people. So thank you. This is the little bar graph thing here for all of Alaska, 1900 to 2023. They painted this on a building in Anchorage that's kind of close to the Fifth Avenue Mall. It's like, you stand there, it's like hugely impactful to see this on the side of a building. It's like, yeah. So I'm gonna leave you with that image and I'll take questions. I'm only 11 minutes over my time. Good job. And that was a lot, it's covering a lot. The impacts are really pretty great. I tried to kind of hone in on the topics that people are kind of most interested in. I could do a whole lecture about one of those basically. So if you have questions, please ask.
I'm curious in particular about the main tree species that grow here, the hemlock spruce and
What was the question?
I'm curious about the main tree species of the Tongass. Are any of them going to be vulnerable where, a few degrees more and you're going to start to see a shift in where they can grow? Or are they resilient enough to handle warmer temperatures?
So the question was about the tree species here and how they're going to react to warming temperatures. And the only one that we've been seeing a problem with, and it's been a problem that's been around since the 1970s, is with the yellow cedar, Alaska cedar, people call it. And that is really sensitive to a freeze when there's no snow, because that freeze can penetrate the ground deeper and kill their roots. And so the hope is that as they die off from those cold snaps, that they will continue actually moving north where there is more snow still to protect their roots from the cold snaps. But so far, that's the only tree that I know of that is being directly affected by the cold and then climate changes. The hemlock sawflies do better when it's a little warmer, and we have those here. So far, the trees that I've seen affected by that don't die. They get quite a bit of defoliate, needles, defoliation happens, but then they keep growing the next year. So they kind of look gnarly, but they survive. Yeah.
Is the European great crab an invasive species in the Pacific Ocean?
Yes.
How long has it been in the Pacific?
They've been in the Pacific since like the 1984, 80 decades. Well, decades. They were introduced to the East Coast accidentally, and then they were accidentally transferred over to San Francisco Bay. They were in the larval stages were in some seaweed that were like wrapped up lobster or something for transportation across on the train. It might have been the 1940s. I'm thinking actually. Dates. I'm like whatever.
They're here.
Are they edible?
And so then the population started in San Francisco Bay, and then the larval stages ride the currents and have been moving up the west coast. And we've been tracking that. We know how far they are each year. People have been waiting for them, hoping they didn't actually manage to cross Dixon Entrance, but they have crossed.
But they're pretty predatory on young dodgerettes.
Yeah. Yeah. And they only get to about 4 inches across the back, so that's probably not something most people are going to try to eat. Yeah. And did you have a question?
A few years ago, at least in Sitka, there was a massive starfish die-off. Do you know?
Sea star wasting disease.
Yeah, was that related to the ocean acidification or the warming or anything?
Warming. What they finally figured out is that the shallower surface waters got warm enough that a particular kind of a virus called Vibrio, is a type of Vibrio, there's a Vibrio something, was able to proliferate and attack the sea stars and cause them to die. The deeper waters that remain cold, the Vibrio was not able to survive and do as well. Did you, Mary?
I have an anecdote. I've been here so long that I do have a story about climate change. I've watched it happen. But I went to school at the University of Alaska in the late 60s, and 50 below was not unusual. It was every day, and I left in 67, and in 68, they had 12 weeks where the average was 50 below. People were leaving in droves, but I mean, it was extreme.
Yes.
But now, if it's 50 below in Fairbanks, it makes headlines.
Yeah.
And then when I worked in Prudhoe Bay, I saw 75 below. But
Yeah.
there was a wind chill behind it, but the actual temperature. And it froze so fast that the tugboats that were bringing in the winter supplies and all that kind of stuff, they froze in the Arctic Ocean. We had to build a road out to them and offload them. Now, 43 years ago, when I was working on the Alaska Marine Highway, floated to Skagway, and that was still when they let people down on the car deck. And this passenger said, "Gee, I never thought we'd see temperatures like this. It's 80 degrees, which isn't too much." But I said, "Yeah, well, they were expecting ice and snow," and I said, "Well, you see the mountains up there, and you can see the same thing on Deer Mountain now." I said, "See all that gravel up there? Yes, it's gray. It hasn't had a chance for things to grow." Now, when I started on the Alaska Marine Highway in 67 or 69, it was hanging glaciers all up there. So I saw it happen in my work period.
Yes.
In that time. But I told the people on the car deck, I said, "It's global warming is what it is." And this was in 1990. And I said, "We kind of like it here because we can grow gardens, but if I were where you're from, I'd be terrified." And I just often wondered if now with the tornadoes and the floodings and the hurricanes, if they don't remember that. But I don't see any political leaders addressing the problem.
And that is kind of the rule of thumb with the weather and climate in Alaska, weather events in Alaska, as well as everywhere else, is like record-breaking hurricane seasons. Oh my gosh, we have more and more tornadoes. Wildfire, always. erratic weather, whether it's way warmer, way colder, way more water, rain, whatever, that erratic weather is the hallmark of climate change.
Yeah.
Yeah. Any more questions? Thank you, Mary.
Oh, actually, I have one. So you had a picture of the state, and you had the general increases in average temperatures, and it was pretty evident as you go more north, the temperatures are rising quite a bit more and quite a lot faster. And it's an interesting backstory to it. I was wondering if you could explore a little bit.
So the kind of, if you look at the whole planet as a whole, the around the equator has always been pretty darn warm, and so it's getting a little warmer, but it's always been pretty warm. The ends were like super cold, and then now things are warming up, and they're like, the amount of change that can happen is greater the further north, the further south you get. Antarctica is also melting right now. I was just reading an article that they were like shocked by how much ice melt happened this last year, and so the Arctic research people are now also reporting on the Antarctic because it's melting both ends because they have so much more temperature change that can happen, basically. Yes.
Would that be partly because of the effect of, if it was blanketed with snow or ice, it's white, it's reflected more.
That is a
So
problem.
as that melt,
Yeah.
there's more dark surface
To absorb. Yeah.
so it would be more like self-feeding system that would get.
Another thing, there is that self-feeding, like you're saying. There's something called the albedo, which is how much of the light that hits the planet actually reflects back off. And anything covered with snow or ice has a higher albedo, so more of the light's reflected back out, right? So that is something that happens. Alaska is one of the only places, like, it's a big state. It's a pretty big chunk of land, but it's surrounded on, like, at least 3 sides by a lot of ocean. So as that ocean temperature rises, it will warm the land more too. I mean, we can see that here. We have a maritime influence climate. We have a maritime climate. All of the ocean that's just like right there warms us in the wintertime and cools us in the summertime. And that's true for like all the way around Alaska then. Okay. So there's a number of different factors that are leading into the fact that the further north you get in Alaska, the more warming is happening more quickly. Yeah. Thank you so much for coming. Thank you to the library for hosting us. I do encourage you to read up on these different topics that you're interested in, become more informed if you want to. If anybody, you can email me or whatever, and we can chat more if you want to as well. But yeah, this is an important topic, and I appreciate you guys all coming and listening.